Okay, so now we're ready to continue our review for the Unit 4 lecture exam in astronomy, and now we want to talk about the Big Bang, so the birth of the universe. So make sure and read the learning objectives for this particular lesson, and then you should be reading chapter 17 out of your textbook. And so you've got to know what is the definition of the Big Bang. So what do we mean when we say that the universe began with the Big Bang? So make sure and know the definition of it. Okay, you got to know the evidence for the Big Bang. So why do we think that a Big Bang occurred? And so it has to do with the Hubble's law, and the fact that the universe is expanding today. So it's logical that if we go backwards in time, the universe gets smaller. Well, where did it come from? So if we take it all the way back to a very small point and then let it expand again, that would be the Big Bang. Okay, then another line of evidence is that when you take objects and you squeeze them, when you squeeze a gas, its temperature goes up. So if the universe is expanding today and it's getting colder, then if we make it smaller, the temperature will go up. And then the third line of evidence is that at higher temperatures, we found in the previous lesson that the forces unify and that particles become more elementary. So what caused the Big Bang? Let's not worry about it. So we're not going to say what actually caused it to happen. We're just going to assume that it did happen. So that the Big Bang is going to occur in two parts. So in part one, the forces are going to come apart, and in part two, we're going to start to build up matter, beginning with quarks. All right, so in part one, all you got to remember is this chart here. And we're going to go in the opposite direction. So we're going to start with toe, and then it's going to break apart into gut and gravity, and then the gut is going to break apart into the electroweak and strong nuclear, and then finally the electroweak is going to break apart into electromagnetic and then the weak nuclear forces. So that's going to be part one. So let's go back here and start to talk about this. So that at the instant that the universe began to expand, we don't know what the universe was like. So you notice that we don't know what the temperature was like. We don't know the size of the universe. We don't know what the universe was made of. And we don't know what the fundamental force would have been that held the universe together. So this is pretty boring. Okay, but when we get to this time period of time is equal to 10 to the negative 43rd seconds after the Big Bang, that is as far backwards in history as we can go. So prior to this moment in time, the laws of physics as we know them today don't exist. But from this time period all the way to the present, we do understand how the universe has operated. Okay, don't worry about the temperature, but the temperature is hot. It starts out being very, very hot, and as the universe expands, the temperature is gradually going to get less and less and less. Notice the diameter is smaller than a quark. The entire universe smaller than the size of a quark, and it's going to start to expand. The particles that is going to make up the universe is going to be matter and antimatter. So you're going to have matter quarks, and you're going to have antimatter matter quarks. And then you're also going to have leptons and anti-leptons, and you're going to have some dark matter, and you're also going to have dark energy. So you're going to have matter and antimatter, and it's so hot that the matter and antimatter goes together to make energy, and then the energy makes more matter and antimatter. Okay? And you're going to have these very same processes, these same particles, all throughout part 1. So we're only concentrating on what's happening to the forces. Let's not worry about what's happening to matter. But matter is going to be matter and antimatter that is constantly making itself and then destroying itself. All right, so the forces begin to separate. So now we've got two fundamental forces. So we're going to have gut and gravity. So then the next step is going to be, we have three fundamental forces. So now we're electroweak, strong nuclear, and gravity. But this is very important. So as soon as gut breaks apart, it causes inflation. And inflation causes the universe, which was doing this, to do that. So it was expanding at a certain rate, and then all of a sudden it really expands, and then it continues to expand at a constant rate. So that's what inflation is going to be. Don't worry about what caused it, but it's going to be whenever gut changed into the strong nuclear and the electro-weak forces. Okay, then what's now going to happen is that the inflation is going to stop at this point, and then finally the electro-weak force breaks apart into the electromagnetic force and the weak nuclear force. So now you've got four fundamental forces that control the universe. So we went from 1 to 2 to 3 to 4. And now we're finished with part 1. Okay, now we're going to go to part 2. And so let's take a break.